And could you tell us what is the best part of your profession, and what are you excited the most in every day that you get to teach it and do research?
Well, I think for me, the most interesting part of my profession is that every time an earthquake occurs, there's something new to study. We learn something new about the earth. Many earthquakes that occur, when I look at them, I say, okay, yeah, I understand why that earthquake occurred and where it occurred, and it's not surprising. But every now and then there's just something that is just amazing and in some cases awe-inspiring. For instance, the big earthquake in Japan in 2011, bigger than I and my colleagues expected. What it did to the Japanese coast, the tsunami, was just amazing. We had seen that happen in other places, but not to that extent in Japan. So every day there's an earthquake somewhere that's interesting like that.
How advanced is today's technology? Is there room to grow?
Well, the things that we're working on now in earthquake seismology that are most interesting are using technology for warning systems. We still cannot predict earthquakes, so I cannot tell you when an earthquake will happen. But if we can have a seismic sensor right next to an earthquake when it does happen, seismic waves travel so much slower than, for instance, electricity over a wire, that we can give nearby cities or population centers or critical facilities warnings, maybe of seconds to perhaps as much as 10 or 20 or even 30 seconds, that strong shaking is going to be coming. In Japan, they have a system like this already operating that stops the bullet trains if there is an earthquake that's detected on one of their seismic stations.
Wow.
So that the bullet train does not derail when the earthquake shaking hits. And so they've actually saved a lot of lives. In 2011, they saved a lot of lives with this technology.
So the current technology obviously helps us make this world a better place, a safer place for people to live. And you said that the seismic activity is not predictable today, correct?
No, we cannot predict earthquakes as of right now. There's no signal that we have seen that consistently happens before all earthquakes and that we recognize as something that says, oh, there's going to be an earthquake coming right, in the minute, in the next few minutes or next few hours or next few days or even next few years. I mean, there are many scientists that are working on this, and there are some good ideas out there. But earthquakes are very hard to predict because they occur underneath the surface of the earth. And we can't look there the way we can look up in the sky and see clouds for a coming storm.
Can you explain to us how does seismographs work in the easiest terms that you can just explain to people around the world?
Yeah, a seismograph is really an instrument that has two components. One component is what we call the seismic sensor, the seismometer, the thing that we put in the ground or maybe on the surface of the ground that detects the ground vibrations. It's like a microphone, which detects voices or detects sounds. A seismometer detects ground vibrations. And then a wire comes out of the seismometer and goes into a recording unit. Years ago, that recording unit might have been photographic, or it might have been a turning drum with a pen that was writing a line. Today, we record on a computer. So we can take the ground motion, convert it into numbers on a computer, and then we can put those numbers over the internet and broadcast them literally all over the world.
Let's talk about warning systems. Could you explain how does earthquake warning system work, the whole path which information makes from seismic sensors to public websites and media, and who is in charge of this process?
An earthquake early warning system is a surprisingly complicated system, and it has taken. The Japanese have an operating early warning system. The Mexicans have an operating early warning system. Such a system has just become operational. Actually, it's been tested for quite some time, but they're now starting to roll out a public phase for it in California.
Mhm.
The problem is, since we don't know where the earthquakes are going to occur, we have to have lots of seismic stations scattered around. And we want to be able to, just by recording an earthquake on one or two seismic stations, maybe three, the closest ones to where that earthquake is centered, be able to, number one, verify that it really is an earthquake and not a truck going by the seismic station or someone kicking the instrument or a lightning strike or something like that. Number two, we have to be able to interpret how close or how far the earthquake epicenter was from the seismic station, because that determines the timing for the warning.
Mhm.
Number three, we have to determine how big the earthquake is. If it's magnitude 4, no damage is going to be caused, so we don't have to issue a warning. If it's magnitude 7, that can well be a damaging earthquake, so we have to issue a warning. And it turns out, because there are just so many spurious things that happen, electrical pulses and as I said, trucks going by and all kinds of things, it's not an easy job to just take the data that's coming in on a seismic station and say, oh, well, that's obviously an earthquake. It's so big and it's so far away. And the Japanese took years to solve that problem. The Californians took even longer because they're dealing with an even more varied environment than the Japanese are.
Right.
And the Mexican system actually focuses on the west coast of Mexico, and it's warning Mexico City, which is quite far inland. So in a sense, that's an easier problem to solve.
Right. Okay. And then who is in charge of the process? How does it get to the public website and to the media?
You know, that is different in every country.
Okay.
In all
Is
countries.
there a specific, like a department, or is it like a specific way, like international, way to communicate that?
Right now, there is not. In all the countries where you have such systems operating,
Mm-hmm.
you have government agencies.
Okay.
In Japan, it turns out to be the Japan Meteorological Association of all things, but that's the group that does seismology there.
Okay.
In the United States, it's the U.S. Geological Survey. But they actually rely on university and private seismologists who maybe work for companies that do seismic research. They rely on them to help them develop and test the pieces of the early warning system. In fact,
Mm-hmm.
the early warning system in the United States here in California has been developed jointly by the U.S. Geological Survey and University of California, Berkeley. Caltech has been involved. Stanford University has been involved. So there's lots of coordination. There's lots of meeting. There's lots of ways that protocols get decided. And usually in all of these countries, there's some sort of a committee that's run by a government agency, but involves a number of different people who set the protocols, set the formats. They look at the formats that other places use, and they say, oh, we like that, or oh, no, we don't like that. And then they're putting out the warning.
Yeah. So in history, and we already talked about this, there was an earthquake in Japan and tsunami in 2011. And the people of Japan showed their moral qualities and united with each other in this extreme situation. They have shown humanity. Do you think you have experienced do you have similar experiences where people helped each other in situations like earthquakes or like tsunami or volcano eruption?
There's a whole area of study by social scientists, really. Some seismologists get involved, where they go to places after earthquakes occurred and just studied how the people responded to the earthquakes. Because right after an earthquake occurs, you don't know where the police are, you don't know where the government officials are. You see a building that's collapsed, you know that there were people in the building, you got to get those out. And people are just amazing at the way they will self-organize, the way that they will figure out very, very quickly who the leaders are, who's got the knowledge, who knows how to get into that building to get people out. And most of the time, right after an earthquake, when there are rescues of people who are trapped in buildings and need to be saved, it is done by pure amateurs. And it's done by people just out of the goodness of their heart. It's amazing. It gives you a great faith in humanity. And, you know, sometimes in the government, people come in later and they're trying to organize things and whatever. And sometimes
and it's already been
do a
done.
great job.
Like, don't worry, we saved each other.
Yeah, and sometimes they mess it up.
Yeah.
They mess it up.
Yeah, that's true, because they try to get
To each other, and human beings have been coping with this problem for a long time. We've developed very many different mechanisms to do this. We've developed religious mechanisms, we've developed governmental mechanisms, we've developed personal mechanisms, and sometimes they work better, sometimes they work worse, and some of that depends upon the people at the time. Some of that depends upon external things like stresses, you know, if you don't have enough food or you don't have...
Attention, please. The library will be closing in 30 minutes. If you need a library card, please visit the information desk on the first floor at this time. If you need to call for a ride home,
One
please
second.
see a staff member to use the phone. Thank you.
Your studio is closing in 30 minutes.
Yeah, we're at the library, so it's closing in about 30 minutes here. Okay, so what do you think, what are the best qualities, what are the best humane qualities that we have inside of us that we can manifest in the emergency situations?
I think that the most important thing that people manifest in emergency situations is selflessness. You know, the ability to recognize that if you came through an emergency unhurt, or maybe with very, very minor injuries, and there are people who are trapped, are hurt, need help in some way, that people are amazing in that they will step in and try to help those people out. That innate sense of caring more about the other people at that point in a very, very stressful situation. And
right.
you know,
and sometimes it probably helps to care more about other people's, because this way you're not, you know, overthinking the situation yourself. You're just giving it, you know, all your attention to help others.
Well, you know, anytime something terrible happens, people are amazing, because even if they're nowhere near a disaster, they somehow want to participate. They somehow want to help, find some way that they can help if they can. And that, I think, is the most important quality.